Hello guys, this is the lab 6 part 2. Our main goal for this lab is to switching from previously used the just a little bit background. Last lab part 1, we were doing like chat OpenAI using the chat OpenAI embedding and also the chat OpenAI as large language model, which will cost us a little bit money, but it works great. So for this lab, per request, our goal is to switch from the OpenAI version to the localized, more private HuggingFace large language models. And also, Professor instructed us it's our own choice to choose which large language model to use. So we did a lot of experiments on deciding which model to use. Speaking of modification and against a lot on last lab, we don't have a lot of modification. Our group did a little bit kind of work. Is like the only change we did was from the last lab, we were doing something like we have the whole already loaded data, loaded PDF. From this lab, we changed a little bit, so it makes there's a little sidebar on the left. We can drop and browse data and upload the data. The PDF, so we can like the user can select which PDF they want to upload. That's the only change made on the code itself. Speaking of the major changes, we comment out previously using embedding of OpenAI. We also comment out the large language model from Chat OpenAI. Of course, that was using our API key we had paid a little bit for. So there's a lot of a possibility. As we know, we did a lot of research on the HuggingFace. It's a small company, but has developed for like around 1 year. So there's like thousands, 10,000s of these different kind of models out there on the HuggingFace pipeline we can choose from. Firstly, there's one important thing as we are doing the research on the models, we find out like there are different ways of importing the models. For example, like a professor has given us 2 ways in the README. The classic Hugging Face pipeline from model ID. That's one way to do it. The second one is like you can download the binder, and then for the binder, you can load the model pass and then specify the batch and also the different few different other variables. I've researched all this kind of possibility, but due to the limitation of our cache and also our memory, each one of these models take probably like 50 gigabytes, so we weren't able to explore all the possibility out there. So we firstly tried a different way to do this. First, we have the auto model for casual LLM from pre-train, and also the auto GPT from casual LLM from quantized from quantized. Yeah, that is from the that was imported from, let's see, from Transformer. That was the originally vanilla form of the auto model. That was developed by some other company other than Hugging Face, I guess. But for some reason, those didn't really work out pretty well. It turns out it takes a whole long time to download the model itself, and the actual running condition was pretty bad. We were first had this idea because we can set up a device map to automatically keep matching to our GPUs locally. But for some reason, we're still exploring on that. It wasn't able to utilize the GPU to its full potential. So that's one way to one thing we need to explore in the future. Now, during our next assignment or like in the near future, in these few weeks, we have to speed up the model. Otherwise, it's gonna take a huge long time to run locally. The second way is from quantizer. The advantage of it is like the possibility of using different kind of model is very versatile, and you can also specify the device in here. If you have a CUDA GPU, you can specify the CUDA number, threads, and traction, and quantize the configuration. And that's 2 things. That's 2 plans we have abandoned because they didn't really work out pretty well. It takes a long time to reload the model. Also, like we at the in the end of the day, we choose to stick with the Hugging Face pipeline from Model ID because it turns out that's the fastest way. And the behavior of it, we tried a little bit. The first time you run this model, it will download the 50 gigabyte of the local cache to the local memory. However, when you run it the second time, and also you specify use cache equals to true, that in the future you will be able to retrieve the downloaded version, and which is takes a long shorter time to run this whole thing. Probably like it's not as good as ChatOpenAI, but it's still pretty fast. And lastly, like we also abandoned the plan of using the local download model because for some reason I wasn't some of our computer, due to the chip limitation, we weren't able to successfully install the where's the README? Install the LLAMA CPP. Probably due to the Python version problem, we're still trying to solve that. That's still remain an open possibility in the future. So that's the tools of importing the large language model we're exploring. So speaking of which model we choose, we firstly stick with developed by LM system, Vincuna 7B that was given in the example, but we found out that wasn't a very efficient model in terms of reading from the PDF analyzing. So browsing on the different kind of model, we found another pretty good one because it's called Vincuna 13B version 1.5, text generation as a task. It's working pretty good. It's better than the 7B, and the behavior of it is pretty close to the ChatGPT. See, here's the example we're given. We don't have time in the demo to demonstrate the whole process again, but here's a screenshot of how we do it previously. See, it's looking pretty good. It did a pretty good job on summarizing the book. We also tested it on a few other things. For example, on my own resume, it did a pretty good job on learning those things. So, but the only limitation for it compared to the OpenAI is that it's taking a long time to run, relatively long time, not very acceptable. So we still have to figure out how to speed this whole thing up. I guess the problem we're facing right now is like we're not pushing the GPUs to its full potential. For some reason, I guess it's a reason related to the CUDA device availability. So we'll try to figure that out in the future. And that's also in the future where we're trying to discover more models which is more suitable for the and text analyzing and generation. Another one important topic I want to talk about is like we have also exploring something about embedding, because right now we're still using the Hugging Face embedding, native embedding, which is the same as our model. But in the future, we will try to switch to the some other kind of embedding model. That's another huge domain we can explore on. Out there's still thousands, hundreds, tens thousands of models we can try to fit our better embedding. As professor mentioned on the class, we can try to use a vectorizing as on the basis of a sentence instead of the words. That might be yield a better result. See like the text chunk size. Where we're gonna do experiment on that before we finalize our final project. That's one important topic. We have learned a lot from this whole process. Also, one thing we need to modify in the future is that like professor came up with a request. We have to have two separate different windows. Right now you can see like just as a sample, we have one window. It's a sidebar on the left where you can upload file. However, in the future, we'll have to modify it so that we can have two different pages. First page is to upload the document, and second page is to chat with the PDF, interact with the chatbot. I think that's pretty fancy. If it can do something like that, it should be easy. It just need more field study on the CSS format and the ST module. ST is just the Streamlit, which is pretty useful. I guess that's all for right now. As a result, we did a pretty good job on with the to summarize that, we did a pretty good job with the 715 model, 13B model. We'll do something more in the future. I guess that's all we need to share today. Thank you guys for listening. Have a good one. Bye. Wait, let me stop sharing.